It's nice to be here today. Thanks for coming out. And we are a fairly established company. We've been around for 130 years, and we're located in Chicago. And like John Deere and some of the other great companies around the region, we have a pretty storied history. The A in A Finkl Sons stands for Anton, and he was an 8th generation blacksmith that came over from Bavaria, and he made a brick chipping hammer in the early 1860s and late 1860s, and he was out of Milwaukee, and the Chicago fire happened, and the only thing that was worth salvaging in Chicago was the brick. So he would take his horse and buggy from Milwaukee to Chicago with his couple of days worth of chipping hammers and sell them to the brickies. So he realized he could save a few days a week transit, and he relocated to where the action was. And we've been there ever since. We established the works in 1879, and we have about 22 acres on the near north side of Chicago. It's a unique facility because we make primary steel here, and we use more electricity than Sears Tower. And people ride bicycles through our complex on their way to work and things, and you can see the city of Chicago in the background. And we located there because the Chicago River was there, and it was good for quenching steel. And we have what's called a urban manufacturing campus. We plant a lot of trees around the plant to sort of beautify the area. And this bridge there says we have planted 2 million trees. It's really up to about 5 million trees. We did a calculation for what our emissions are, and each tree relieves that much or offsets that much emission. So for the last 15 or 20 years, we've planted millions of trees around southern Illinois and northern Wisconsin. So we'd like to say we were green before it was cool to be green. Been at the present site for about 100 years. We have 5 strategically located warehouses around the country, and we've put these in areas where a lot of the action is. We have one in Los Angeles, one in Minnesota, one in Detroit, one in Cleveland, and then the main one is in Chicagoland. We are a primary melter of steel. So we take steel turnings and scrap and other things that are bought on the Chicago heavy melt market, and we melt that. We melt about 1.5 million pounds every night. We then keep that steel hot, and we forge it into different shapes. We heat treat the forgings after that, machine them, always rough machining, not really finished machining, and I'll talk about that a little later. And then we do some quality testing to make sure it meets the specification. We participate in a lot of different industries. For instance, in wind, we not only make some of the gears that go in the gearbox, but we're real interested when the hot rolled plate is being rolled over at the steel mill, because we make the rollers that form the A36 plate that makes up the tower sections. And we're into many heavy-duty industries around the world. So we pour castings, which are referred to as ingots, from as light as about 20,000 pounds all the way up to 200,000 pounds for a single piece weight. That upper right-hand corner has a 100-inch diameter ingot that's about 10 feet long, and there's some folks standing behind it for scale there. The lower pictures are what, on the lower left-hand side, shows us stripping the casting molds that we pour into off of the ingots while they're still glowing like that. And the picture on the lower right-hand corner is the setup of that 100-inch diameter ingot mold. The material is then taken back up to 2,300 degrees Fahrenheit, which is the plasticity level, and that's where the wrought process occurs, and we forge that on what's referred to as open die presses. So they're just flat dies. We also support the closed die folks who might make some of the smaller components in a wind turbine, like some of the studs or maybe some of the real smaller pinions and gears, in that we'll make the forged die blocks that they carve a cavity inside and then hot work their own steel in. The, the gears inside a utility scale turbine can be pretty big. The stack on the left are gears that are in the 50-inch diameter range. The one in the lower left-hand corner weighs about 20,000 pounds. In the upper right-hand corner, that's a pinion shaft that's helping keep the lights on. That would be a rotor shaft that is responsible for generating electricity. The gear in the lower right-hand corner would be typical of a planetary gear set. The quality level of the gears in the utility scale gearboxes today is the highest quality level we work with. We have rotating parts that have been in service at power plants for 50 years that aren't specified out as hard as the gearbox elements in a new wind turbine. One of the nice things we do is at these warehouses around the country, we stock large diameters of this steel, and then when somebody calls up with a repair, we slice off a chunk. They get a gear blank in a couple of days. They can start hobbing on that and then go on to carburize, and you can have a replacement enter the field in a couple of weeks. The people from the tech schools and if anybody in here has any kind of machine shop or a large lathe or as a gear hobber, I'd sure like to talk to you, because the numbers that they're talking about putting up in the air are something like 8,000 or 10,000 a year to make that 20% wind or alternative energy factor by 2030. We might have a shot at making 500 or 1,000 main shafts a year. That leaves maybe 9,000 shafts that still would need to be made at one of our competitors or somewhere else. One of the major constraints is getting these things machined. If you have a lathe that can turn 60-inch diameter and maybe 12, 14 feet long, that would qualify for this. We'd love to work with you and outsource that portion of the work. We have 8 full-time metallurgists on staff. The ISO and DIN specs that we've seen being pushed by the European manufacturers of these turbines has really made us have to step up our game. It wasn't that we were kind of lackadaisical over the years in what the industries we were catering to, but now they're talking about real low oxygen levels, things that we have to improve our process on to make. And again, we have people moving gearboxes that are all over the world that aren't specified as heavily as the elements in a gearbox in this industry. We stock material up to about 40-inch diameter. So that log or large bar on the lower left-hand side would be about 40-inch diameter by about 16 feet long, probably weighing somewhere around 50,000 pounds. The picture in the lower right would be cut blanks that would go on to be machined into bearings or gears or rollers or some other ultimate shape for various industries. Because the potential looks so good in supporting modern energy, we are in the midst of at least a 200% expansion. This is our new plant that we're building. Now you can see Chicagoland in the background of this slide. This new plant is about 18 miles south. We're actually moving into a big facility that somebody else moved out of. This is about 60 acres, and we're going from about 250,000 square feet under roof to 500,000 square feet under roof. We've already started framing a new scrap yard that's going to be enclosed. The building in the top right is about a quarter mile long. We have just tremendous cranes in there that were existing, up to 500-ton cranes, some of the biggest ones ever made. So when they talk about going to these offshore turbines, we like to hear that. We like some of the bigger forgings, and we'll be able to handle those. And we start out with tiny little pinions in the lower left-hand corner that might just weigh 500 pounds, which is small for an open die forging, and then go up to these forgings that weigh, maybe 125,000 pounds. But we really believe in alternative energy. We've supported the green movement for many years, and we just hope it kind of the financing comes back around and the utilities can start to make some purchases and have more wind farms develop. Thank you.